So today we are going to discuss again the remaining part of naphthalene, that is naphthalene part 2. In today's lecture we are going to discuss how the position of double bond in the naphthalene is confirmed. Then we are going to discuss how the nomenclature of naphthalene should be done by common method and by IUPAC method. Again, we are going to discuss what are the physical properties of naphthalene, and followed by then we are going to start chemical reactions of naphthalene. So in today's lecture, we are going to discuss these many points. So I'm starting now. So how the position of double bond in the naphthalene is confirmed. In yesterday's lecture, we have discussed that naphthalene structure, how it is confirmed, and this work हे जे काही confirmation आहे, it is done by Erlenmeyer and Craig. So they have confirmed the position of double they have confirmed the structure of naphthalene. So for that they have done some reactions and some conclusion they output that this will be the structure of naphthalene. Now today we are going to confirm what will be the positions of double bond, what are the resonating contributing structures for the naphthalene. Now in yesterday's lecture also we have discussed that these are the three resonating contributing structures of the naphthalene depending upon the position of double bond. Now out of these three structures, which structure is stable or which structure is more contributing in terms of resonance, this we are going to discuss today. So it should be noted that there are n plus 1 resonating structures in the naphthalene. So n plus 1 principal resonating structure, whereas the number n belongs to a polynuclear hydrocarbon containing number of benzene rings. So this n belongs to how many number of benzene rings are there in given structure. Now we know our given structure, that is naphthalene, has 2 benzene rings. So how much resonating structure the naphthalene is going to have, or naphthalene is going to possess? N plus 1, that means 2 plus 1 is equal to 3. That means naphthalene is going to give us 3 contributing resonating structures. But out of these 3, one resonating structure is more contributing, more stable, and this is confirmed by the Fries. Lakshat येते what I am going to discuss with you. Yesterday we have discussed there are 3 resonating structures are for the naphthalene. हे कशावरून? Depending upon this rule or this formula, that is n plus 1, where the n is equal to number of benzene contributed in the structure, given number of benzene rings in the structure. In given structure, there are 2 benzene rings. That's why the contributing resonating structure for a structure of naphthalene are 3. But out of these 3, one structure is more contributing one, one structure is more stable one. Which one is out of this? This we are going to study in this part. And who has confirmed there out of this structure one is more contributing? This is confirmed by the Fries in 1935 and he has put forth त्याने आपल्या समोर एक रूल ठेवला for the confirmation of more contributing structure of naphthalene. So what he has done, काय केलं त्याने? Fries compared the possible arrangements of double bond in polynuclear compound with benzophenone. So what he has done? He has compared all these 3 structures of naphthalene resonating structures with benzophenone. त्याने comparison केलं या structureचं with this benzophenone, that is orthobenzophenone. Since benzophenone structure 2 and 3 have arrangements corresponding to the orthobenzophenone. So out of these three resonating structure number 2 and structure number 3 is resembling, is looking similar with that of this orthobenzophenone structure. So depending upon this, or due to this, as these two structures are resembling, are looking same with this benzophenone, since phenols are far more reactive than the purely aromatic compounds. So what Fries has believed? Fries has believed that stable form of polynuclear compound did not contain this phenanoid arrangement. If we are discussing about the stability, that means these two structures are unstable as they are resembling with the structure of benzophenone. See, if we are going to discuss, this one is the first benzene ring, then these two carbon atoms are going to have a same looking like structure with the benzophenone. Now, if we are going to discuss this ring number 2 as a stable benzene ring or first benzene ring, then these two carbon atoms are going to resemble the structure of benzophenone. That's why as benzophenone is more stable, more reactive, sorry, as benzophenone is more reactive, that means these two structures are also having more reactivity as like that of benzophenone. That's why he therefore formulated one rule, and that rule is known as Fry's rule. What is that rule? The most stable arrangement of polynuclear compound is that what he has put forth in front of us, the most stable arrangement of polynuclear compound is that from which has the maximum number of rings in the benzenoid condition. That is 3 double bond in each individual ring. So what is according to Fries, which one is more contributing structure with respect to naphthalene? The structure which is going to have 3 number of double bonds in individual ring. The structure which is going to obey this Fries rule, that structure is more stable. Now, when we are going to compare these three structures, the structure number 1 is going to have the one double bond which is shared between the fused carbon atoms with these two benzene rings. This double bond is going to share with the first benzene ring also, and it is shared with also second benzene ring. No doubt there is a continuous migration of double bond in all these structures of naphthalene, but the structure number 1 in which these fused carbon atoms are going to share this double bond with all the or with individual benzene rings, this according to the Fries rule, naphthalene tend to behave structure 1 with 2 benzene rings other than or rather than structure number 2 and 3 with the 1 benzene ring. The structure number 2 and structure number 3 in which they are contributing structure, but in these two structures, these structures have only one stable benzene ring. But with respect to this structure number 1, as the double bond position is between these two carbon atoms, both the rings behaves as both the rings are showing the properties of benzene ring. That's why according to Fries, this structure is more stable as compared to these two remaining resonating contribution structures. So they may ask in the exam, write the resonating contributing structures of the naphthalene, how many are there and which one is more stable. So that time you have to to state this rule and you have to draw these resonating contributing structures. So this is with respect to the position of double bond and resonating contributing structures with respect to the naphthalene. Now we are going to discuss isomerisms. What is isomerism? The compound which have same molecular formula but different structural formula. Those compounds are known as isomers of each other. Now, as there is presence of double bond in these rings, naphthalene is going to show resonance. Now, what are the naphthalene is going to show the isomerism and how the structure of naphthalene is to be nominated. Nomenclature कशा पद्धतीने केलं जातं that we are going to discuss. Now, according to older nomenclature system, previously they are going to nominate the structure with respect to the nomenclature, that is alpha and beta. So according to old system, position 1, 4, 5 and 8. Now in given structure, position 1, 4, 5 and 8 are nominated as the alpha positions of that naphthalene ring. Now followed by position 2, 3, 6 and 7. These lateral positions are nominated as a beta position. And in all the literature, the position 1 and 2 will be referred as ortho position because this first carbon atom is ortho at this benzene ring and this second carbon atom is ortho with this particular benzene ring. So this, according to older nomenclature system, position 1 and 2 are referred as ortho, position 1 and 3 are referred as meta, and position 1 and 4 are referred as para position. Then, position 5 is referred as ana. See, 1 and 2 are ortho, 3 and 1 are meta, 1 and 4 are para with respect to this benzene ring. Then position 5 is known as ana, 6 is referred as ep, 7 will be referred as cata, and 8 will be referred as peri. Then position 2 and 6 are amphi, position 2 and 7 are pros. This is with respect to older nomenclature system. Just for information sake, we have discussed this. Some of these prefixes. So these prefixes, that is ortho, meta, para, alpha, beta, some of these prefixes are still used. So yesterday, when the structure of alpha naphthol has come or 1-naphthol has come, I have pronounced that alpha naphthol. So out of these all nomenclature systems, some of the prefixes, some of these letters are still used for the nomenclature system. So some of these prefixes are still used, but it is best to use numbers. But IUPAC nomenclature system is preferring the numbers. The Greek letters, that is alpha and beta, are still frequently used to indicate the position of single substituent. If there is substitution in given naphthalene ring, and if the substitution is single, then we are going to nominate those substitutions with the help of alpha and beta Greek letters. Now, if naphthalene ring is mono substituted, only single substitution, if it is done in the structure of naphthalene, then the structure of naphthalene is going to have 1 and 2 isomers. So if we are going to substitute the naphthalene with mono substitution, then it is going to have 2 isomers at position 1 and 2. Then if naphthalene ring is di-substituted, two substitutions are there, then naphthalene is going to give us 10 isomers. So different depending upon the position of double bond, depending upon that substitution, that di-substituted naphthalene, that is X2, will be producing 10 isomers. What are isomers? Same molecular formula but different structural formula. Then if it is di-substituted but with different substitutions, see in this case the substitutions are same X2, but if the substitutions are different, then naphthalene is going to give us 14 isomers. So there are 14 possible isomers for tri-substituted naphthalene, 22 isomers for tetra-substituted naphthalene, 14 isomers for penta-substituted naphthalene, 10 isomers for hexa-substituted naphthalene, 2 isomers for hepta-substituted naphthalene, that is 7 substitutions, and 1 substitution is for 8 substituted naphthalene. So this is for information sake only. If we are going to, for certain period of time, if we are increasing the number of substitutions, isomers are increasing, but at above the certain level, there is decreasing in the number of substitutions. Now we are going to discuss physico-chemical properties of naphthalene. Up till now we have discussed structure confirmation, synthesis of naphthalene. Today we have discussed resonating contributing structure. For that we have discussed price rule. Now we are going to discuss the physico-chemical properties of naphthalene. First we will the physical properties. Naphthalene exists as a lustrous plate. So it is going to have the luster, means shining plates are there, having melting point 80 degrees centigrade, which is insoluble in water, as he is going to have non-polar structure containing 10 number of carbon atoms. It is insoluble in water but soluble in hot ethanol, cold ether, benzene, etc. So as it is an hydrocarbon containing compound, Pauling chain containing compounds, that's why it is soluble in number of organic solvents. It has characteristic odor and is very volatile. It is volatile in nature. It is used as an insecticide in the preparation of phthalic anhydride and dye. So it is used as an insecticide. Naphthalene resembles benzene in many of its reactions. As naphthalene is going to have fused, condensed 2 benzene ring in its structure, this is going to show majority of the properties of benzene. It is going to resemble the benzene in many reactions. But when we are comparing naphthalene with benzene, naphthalene is more reactive than the benzene, as he is going to form addition and substitution products more readily than the benzene. It is more readily oxidized and reduced at what position? Position number 1 and 4. So this benzene, naphthalene is oxidized and reduced at what position? Position number 1 and 4. Addition compounds of naphthalene. So this will be the first reaction of naphthalene. What happens when naphthalene is undergo addition reaction? A number of reduction products of naphthalene can be isolated. The nature of the product depending upon the reducing agent. So when we are going to reduce or when we are going to add hydrogen in the structure of naphthalene, number of compounds will be produced. When naphthalene is reduced with sodium and ethanol, so we are going to use sodium metal and ethanol as a solvent. hydrogenation will take place. Addition of hydrogen will take place with respect to these double bonds, and naphthalene is converted into 1,4-dihydronaphthalene, and they are going to produce 1,4-dialine. What is the name of this compound? 1,4-dialine, having melting point 25 degrees centigrade. So what will be the first chemical reaction of naphthalene? It is addition reaction, hydrogenation reaction, addition of hydrogen at position 1 and 4, and the number of the double bonds which are there at position 1 and 4 are saturated. Naphthalene is converted into 1,4-dialine, having melting point 25 degrees centigrade. This 1,4-dialine is unstable, readily isomerizing to 1,2-dialine, having melting point 8 degrees centigrade. When heated with ethanoic sodium ethoxide, 1,2-dialine is also unstable. See, here we are hydrogenating this naphthalene with sodium and ethanol. But if we are going to provide greater heat or more heat to this mixture, then again this 1,4-dialine is unstable and fairly eliminating hydrogen. Again they will eliminate those hydrogens which are added with respect to these two carbon atoms, and again this 1,4-dialine is converted into naphthalene. So this is not a specific reaction. If the this reaction is depending upon the temperature. If we are going to heat this reaction more, so this added hydrogen atoms are again removed, and this 1,4-dialine is converted into again reverse back into the naphthalene. So this will be the first reaction. When second possibility, when naphthalene is reduced with sodium and isopentanol. In first case, we have reduced the naphthalene with sodium and ethanol. Telluric forms along, naphthalene is going to give us 1,4-dialine. This is first possibility. Second possibility is when naphthalene is reduced with sodium and isopentanol. So that time naphthalene gives us 1, 2, 3, 4 tetrahydronaphthalene. So the double bonds which are there in the ring B are totally saturated, totally hydrogenated, and naphthalene is converted into 1, 2, 3, 4 tetrahydronaphthalene. This compound is known as tetraene, and having the boiling point, that means this compound is converted into liquid state whose boiling point is 206 to 208 degrees centigrade. So this is with respect to addition reactions of naphthalene. These reactions are asked in the exam. Write the chemical reactions of naphthalene. So first reaction is addition reaction. In that we have added hydrogen atom across the number of double bonds in the structure of naphthalene. This is first reaction. Now second reaction of naphthalene, that is oxidation of naphthalene. So naphthalene is oxidized by, what are the requirements? It is oxidized by concentrated sulfuric acid and mercury sulfate. So for the oxidation, there is a requirement of sulfuric acid and mercury sulfate, or by the air in the presence of vanadium pentoxide. When naphthalene is oxidized with the help of sulfuric acid, mercury sulfate, or in the presence of vanadium pentoxide, naphthalene is going to give us phthalic anhydride. So if we want phthalic anhydride, that time naphthalene is treated with, or it is oxidized with, sulfuric acid and mercuric sulfate. This is going to result into production of phthalic anhydride. when it is oxidized by acid permanganate to phthalic acid and by alkaline permanganate to phthalonic acid. If it is oxidized in the acidic media, naphthalene is going to produce phthalic acid, and if it is oxidized in the alkaline permanganate media, naphthalene is going to give us phthalonic acid. Now, interesting reaction, when naphthalene is oxidized with the help of chromic acid, this chromic acid oxidizes naphthalene to 1,4-naphthaquinone. And when treated with ozone, so here will be the reaction. When naphthalene is treated with ozone, naphthalene forms the diazonide, and this on treatment with water, this is going to produce as naphthaldehyde. So four reactions with respect to oxidations we have discussed here, and the page number is displayed here. So this will be the reaction when naphthalene is going to oxidize with the help of ozone. Naphthalene is going to produce diazonide. This is an intermediate product. And this diazonide, when it is treated with water, when it is washed with water, diazonide is going to give us naphthaldehyde. So this will be the second reaction with respect to the naphthalene. Now we are moving towards the substitution products of the naphthalene. Up till now we have discussed the ring reactions, whole ring reaction with the naphthalene. In that we have discussed addition reaction and oxidation reaction. Now substitution reaction of naphthalene. Substitution products of naphthalene. Orientation in the naphthalene nucleus is more complicated than the benzene nucleus. Now, when we have studied the benzene and its derivative topic, that time we have discussed in depth about the orientation pattern of benzene ring. But when we are comparing the orientation of naphthalene with benzene, naphthalene's orientation is more complicated. Why? Because naphthalene is going to have two benzene rings due to the presence of two rings in their structure. The first group always enter the first position in the naphthalene except in the two cases. Generally, whatever will be the substituent group, it will enter, it will react with the first position of the first carbon atom of the naphthalene. But except in two cases. What are those two cases? When the second derivative is the main product, when the second carbon derivative as a main product, that is sulfonation at high temperature. कधी कधी होणार है second derivative as a main product, sulfonation at high temperature, and in the Friedel-Crafts reaction. Introduction of second substituent can give rise to homonuclear, that is isonuclear substitution. The second substituent entering the same ring as the first, or to the heteronuclear substitution. The second substituent entering the other ring. The following empirical generations were helpful for predicting the positions taken up by the second substituents. So this substitution reactions tomorrow we will discuss in detail. Before that,